Right, here we go. Final lesson of chapter 2. Just picking up where we left off yesterday, I got 3 examples for us to do on the next page. I wanted to show you this first. When you have an inequality to solve, one of the things that we always want to do, two things we always want to do. One thing we talked about in the last video was always make sure it's being compared to 0. So that is super important because when we decide where the positive and negative areas are, that's only going to make sense if we're being compared to 0. So make sure before you do anything else in these problems, everything goes onto one side and it's being compared to 0. So that's the first thing. Second thing is we also only want one fraction. We don't want 2 different fractions. So if we're given multiple fractions, we want to combine them into a single fraction first before we go through the rest of our process. So I wanted to remind you really quick how we do that. And it really just goes back to something you would have done last year with rational expressions, where we are creating common denominators. So as I look at these guys, if I need a value that both of these can go into, it's really just going to be the 2 of these things put together. So the combination of x minus 3 is our common denominator. And so that's what you see right here is the x minus 3. Those 2 things put together is the common denominator. How do we get the numerator? So for this guy, he needed the x. And remember, whatever you do to the bottom, you got to do to the top. This guy needed x minus 3. So we'll do the same thing to the top. And so now when you look at those, that's where they got this line right here. So it's just that one step of creating common denominators, then you can multiply them together, or sorry, combine them together. So this becomes the denominator, x minus 3. On top, I do distribute this negative, so I'm looking at 3x minus x plus 3. That's where they got this line right here. And then simplify that, and now we have everything formatted the way that we want it to be in order for us to do our process. So want to make sure those 2 things happen first. It needs to be compared to 0, needs to be a single fraction. And then you can go on and do the rest of what we're doing. And really the steps that follow from there is exactly what we did in the last video. We're looking for key points, want to determine what sections of the graph are positive and negative. So it was all this kind of stuff that we did yesterday. So let's go down to this one right here and go through the whole thing. So let's get a good look at the entire process from start to finish here. So first things first, remember the 2 conditions we want. I need this thing being compared to 0. So I want to subtract that 3 over to the left. So I'm going to be looking at x plus 1 over x minus 3 minus 3 is greater than or equal to 0. So that was the first condition. The second condition is I don't want 2 different terms. I want one fraction. So I need to be able to combine these into a single fraction by creating common denominators. Between those 2 things, my common denominator is simply x minus 3. So the first guy is already there. So he is x plus 1 over x minus 3. My second fraction, we are multiplying by x minus 3 over x minus 3 in order to create that common denominator. So x minus 3 is going to be that denominator. Let's just clean up the top. Remember the negative 3 is what's being distributed. So this is going to be a negative 3x plus 9. So on top, I got the negative 3x plus 9. Denominator doesn't change. That puts us here. And then one last step in order to simplify. So it looks like a negative 2x and a positive 10 over x minus 3. And this whole thing was greater than or equal to 0. Okay, so that was the first thing, is just making sure everything is formatted the way that we need it to be before we do the rest of this. And so from here, we need to look at what are the key numbers within this. And remember, the key numbers are all about finding where we could potentially have sign changes. So things like x-intercepts and vertical asymptotes are the two things in a graph that can have a sign change from positive to negative or negative to positive. So that's what we're looking for. So if we set this equal to 0, we can see that positive 3 is going to be our our vertical asymptote. So remember, we do want to know that is not an intercept. That is an asymptote. So at 3, this graph is undefined. And you'll see why that matters at the end. We talked about it in the last video, but we'll see it all play out within this problem. So that's our vertical asymptote. What about the x-intercept? Remember, x-intercept is where we're setting the whole thing equal to 0. Multiply that over, it's still 0. So if I set the numerator equal to 0, then we would get 5 as our x-intercept. So let's identify that guy. And we want to remember that this was a 0. So that will matter at the end as to which one was undefined and which one was a 0. That will play into our answer. So that's important. So remember, this is what we call either a little sign chart or a sign graph, something like that. And we're calling it that because we want to know what are the signs of the graph in these 3 intervals. So we need to look at the interval from negative infinity to positive 3. Then from 3 to 5. And then at the end, we're going from 5 to infinity. All right, so we are looking for where is this thing positive, where is it negative. So what we're doing is, remember, we're picking numbers in these intervals, plugging them in for x to determine whether it is an overall positive or an overall negative section. So when I do that, so if I pick a number like 0 and plug it in, remember, we don't really care what the number is, we care whether it's positive or negative. So all we're really doing is testing signs. So if these are both positive, well, we know that a positive divided by a positive is still positive. If I have either one of these as a negative and the other is positive, we know it's overall negative. And if they're both negative, it's positive. So that's really what we're looking at, and that's what these are for. We could just plug in the number and simplify it. This is intended to sort of break it down step by step. So I need to look at my negative 2x plus 10. And I need to look at the x minus 3 for what I would be plugging this into. So if I picked a number like 0 and plugged it in right here for x, I can see that the numerator would be positive and my denominator would be negative. So a positive divided by a negative is overall negative. So we want to identify that in our little sign graph right there. Pick a number like 4. So negative 8 plus 10 would be positive. 4 minus 3 is positive. So overall, he's positive. Pick a number like 6. So negative 12 plus 10 is negative. 6 minus 3 is positive. So he's overall negative. So we have those sections now identified. So here's the key. We now have to answer the question. So this one was saying, and we're looking at this, in what sections of the graph are either greater than 0, so we know he's a winner, or equal to 0. And so this is where this will matter, right? If it's equal to 0, then we include it in our answer, and that means a bracket. This guy doesn't even exist on the graph. It's undefined. So he cannot come with a bracket. Even though there's an equal sign, no point on this graph equals a value at x is 3, right? He's an undefined point. So it doesn't matter that there's an equal sign. He's undefined. He doesn't exist. He does not get a bracket. He gets the bracket because he's a 0. So that's matters as far as this answer goes, because the positive section of this graph is only from 3 to 5. But our 3 is undefined, so we cannot include it. our 5 is a 0, so we do include it. So that's where this idea matters. And so that's where we have to recognize whether it's an asymptote or an intercept, because it will affect our answer. If this equal sign was not here, then that really wouldn't matter, because we would be using parentheses around it the whole thing no matter what. But when there's that equal sign, then it does matter which ones we include and don't include. So this one, so let me give you the last two. These last two are mostly sort of special cases. The process is the same, but I wanted to show you a couple tricks that are going to pop up along the way. As we look at this one, I can still see my two factors, or x minus 3 and x plus 1, right? So I'm taking those two factors into account. So here they are within my setup, just like we did on the last problem. I'm still looking at my key numbers as positive 3 and negative 1. Those are still my key numbers. And both of those are zeros of the graph. So the issue, however, on this is because this one is under a radical, we know that x cannot be below negative 1, which means as I look at my three regions that I'm going to test for positive and negative, I have to remember that because of that radical, this area of the graph doesn't even exist, right? And so, and I'll even show you that graph here in a second so you can see it. But this doesn't even exist. So really when it comes down to it, I need to recognize that part is undefined. So I'm only going to test those two sections for positive or negative. So if we go through our process that we would typically do, so pick a number like 0 in here, and we're going to plug it on in. 0 minus 3 would be a negative. 0 plus 1 square root would be a positive. These guys all have to be positives, right, for that column. So overall, that section's negative. For the last guy, pick a number like 4. 4 minus 3 is positive. That's always positive. Overall positive. So here are the two key sections of the graph. Now we look at this, and this one in particular said greater than or equal to 0. That would only mean this interval right here from 3 to infinity. And then here's where this being a 0 matters, right? It's not undefined, it's a 0. So because there's an equal sign, we need to include it. So as far as our solution goes, we are recognizing the interval from positive 3, inclusive, to infinity. And so that's what our answer should look like. And so I'll show you that graph real quick. This one was out of our book. Looks like this. All right, so you can see that below negative 1 doesn't exist. So let me show you one more, and we will call it good for the chapter. So the other issue that came up on this one was now you see those absolute value signs. So let's see how that would affect us. Still looking at the same key information, right? My vertical asymptote is at negative 3. So he's still here, and I want to recognize that it's undefined. My x-intercept, if I set this equal to 0, is positive 2. And I want to recognize that he does exist. That's a 0 of the graph. So I want to recognize that. So key numbers were just those guys, the negative 3, positive 2. So as I look at all this, how is this being an absolute value going to affect this scenario? So still want to set up our three intervals. We have from negative infinity to negative 3. We got from negative 3 to 2. We got from 2 to infinity. So we got those three areas. So really the only impact that this is going to have is if it's an absolute value, we know this is positive all the way down, right? So that's really the impact that he's going to have, is this must represent a positive value. Doesn't even matter what number we plug in. The absolute values would turn it to a positive no matter what. So we really only need to test this guy to see how it would affect us. So if I pick a number like negative 4, plug it in, it's going to be a negative. So this section is overall negative. Pick a number like 0, 0 minus 2, same result. And pick a number like 3, we get a positive, positive. So again, now just to go on to answer the question, what sections are less than or equal to 0? What sections are less than or equal to 0? So obviously these two sections are less than or equal to 0. Because of the equal sign, this is where we have to take into account this idea, right? Do we include the -3 or not? Even though there's an equal sign, we can't include it because it's undefined, right? It's not a 0, it's an undefined value. So I still have to separate out this answer now into two different parentheses because we cannot include that -3. So I need to see this region of the graph going from -infinity all the way up to -3. We're going to union that with this section, which goes from -3 to 2. And here's where you got to be careful. Do we put brackets around the 2 or do we put parentheses? It is a 0. There is an equal sign, so we do include the 2. So that's the way we should properly write that answer. But that is it. That's it for chapter 2.